I guess we can get started. We have a small group, but that's good. So welcome everyone. This is our fourth stakeholder meeting and probably the last. We have now met, we've now discussed quite a few aspects of the simplified PRM. And at this point of time, there are a couple of more things for us to discuss today, after which uh, will be sending out the draft rule set standard for your review. Um, so we have a short agenda today. Uh, the topics we have to discuss get into lighting, HVAC systems, and renewables. So that's going to probably take up quite a bit of our time. I'll also share my screen. Yeah. And you see the right screen, yeah? Yeah, you see this one. Okay. And so let's see. All of us have been on previous calls, so there's no one new that we need to do introductions for. Just to tell you what happens next. So far we've talked about everything that we've spoken about and things that we would discuss today. We've kind of started writing that up into a rule set. We've followed the Appendix G structure as much as possible, just because people are familiar with it. And towards the end of the meeting, we'll also just go through what that new structure looks like. And next step would be to send this out to all of you for review. We will incorporate your review comments, and once all of us feel good about this, we will share this with Mike Toulouse and Mike Rosenberg will bring this up to the 90.1 ECB committee. As you know, once this becomes a part of the ASHRAE standards process, it can't be shared outside of the committee membership. So that's why we want to get all of your comments in before we share this with ASHRAE. And they'll then take it through the process of the ASHRAE committee vote and review, etc. For our next year, we'll be looking at validating the simplified approach. So throughout our meetings, we've identified some instances where we've questioned what the impact of the simplification is on the energy use of a building. So we've been keeping a note of all of those things that we've identified, and we'll be running a large number of models to validate the simplified approach, just identify the impact on the EUI, energy cost of a building, when we make these simplifications. And Chris Ballback at the last meeting reminded us of a similar analysis that NREL had done for the asset score tool, where they looked at the simplifications the asset score tool was making, and what the impact it had on the energy use of the building. So I'm sure there are more studies like that out there. So we'll do a review of all of those studies as well. And after the some validation analysis, we also want to do a pilot. So this rule set is for code compliance and for beyond code programs. So we'll be reaching out to quite a few of you who've either been part of or utility programs, or have, or even Gale through USGBC, if there's any interest in piloting this simplified approach. So we'll be looking at that in FY22. So that's going to be the work going forward. For the scope of the PRM, we have so far discussed the space use classification. So we discussed the fact that we want building area types to be used to identify the use type of a building, and schedules and loads would be prescribed. So Fred, you'd recommended prescribing schedules and loads, but allowing a user to modify them and providing more information if and when they're modified. So that is something we still need to figure out. But right now we're going with the fact that schedules and loads would be prescribed. We'd also discussed that even if we use building area type classification at a high level, we still want a user to identify, well, actually, no, that's something we're going to discuss today. So I won't jump the gun. We'll talk about the space types for lighting today. And for geometry, we discussed this last time. So just a quick reminder for everyone, we had mentioned that we would allow a certain percentage variation in the surface area, building volume, opaque area, fenestration area, which might be a property of the simplification. So we spoke about that, and we said that that acceptable percentage is something that, again, we should identify through the validation studies. For envelope, we had discussed the possibility of requiring a user to define the envelope constructions at a layer-by-layer detail versus just an assembly U value. And we did not reach a definitive solution in this either, because the team felt like the impact of that layer-by-layer definition might not be significant enough, and just having an assembly U value where we also account for thermal mass might be a way to go. So again, these are options that we need to look into further. Anything any of you want to add in terms of key decisions we've made so far or what we've discussed? Okay, so for today, we'll be talking about lighting systems and also HVAC systems for both proposed and baseline. And service hot water, we wouldn't get into today. This is something you might just end up reviewing in the rule set. So just to get into the lighting system, so we looked at several tools, Sapphira, Ripple, and Praxis, and several more, and most of them have a lighting power density input at a building area type level of detail. So there's a single LPD input, and they also have some kind of defaults for if the lighting type is efficient, energy efficient, standard lighting types, which have an associated percentage reduction for the lighting power density, and kind of adjust it for controls or any other kind of efficiency level. So this is what we've seen. And the other level of detail is in eQuest, where a user is required to specify the space type breakdown for each building area type, and then also specify the lighting power density for each of the space types. And this is in the design development wizard. Most of you would be familiar with this. And then eQuest then calculates the lighting power density for the entire building area type based on the space type composition. So looking at this, we thought that this might be a good approach for SPRM. So we could follow the eQuest approach. We could require a user to specify the building area types, and as well as the space type breakdown within the building area types. What this allows us to do is ask the user for the lighting power density for each of the space types. And the simplified modeling tool, which implements this rule set, could then calculate the lighting power density at the building area type or at the thermal block level. This also allows us to use the lighting control reductions, which are specified in Appendix G, at a space type level. So this way we could maintain that that level of distinction where controls are identified at where controls are applied at the space level, and we could just also use the reductions which are specified in Appendix G. So there can be credit for lighting controls at the space type, but the limitation of this approach is the fact that a user would need to, so the modeler or the architect would still need to go through the process of defining the space type composition for each building area type. Any thoughts on this process or any input in this approach?
Yeah, and I might have just not fully understood. Are you still allowing a whole building LPD approach, or is it only allowing space by space?
So we were thinking we would only allow space by space, right? And the reason would be, again, so one is, of course, lighting controls. The other reason was we could then also have for the assumptions like plug loads and ventilation loads, instead of having a building level value, we could actually have space by space level prescribed defaults. So if a user gives us the space type breakdown, then we could also calculate the plug load for the entire building area type and also the ventilation requirements for the entire building area type.
I understand the advantages. I mean, it's kind of going the opposite direction of simplification. So
Right.
That's what jumps out at me anyway.
Yeah.
The other thing that's crossed my mind is, as lighting keeps getting more and more efficient, LPDs get, lower and lower, the value of controls drop. You're taking a percentage off of a smaller number. What level of impact is it having on overall on the accuracy of the model if we do a whole building versus a space by space with controls?
And the
Yeah,
other
I tend to
potential
agree with
issue
that.
is a little bit too much oversimplification, because you're comparing against the ASHRAE 90.1 Appendix G baselines associated with 2004. You're also looking at daylighting controls that should be modeled for daylit spaces, which could be substantial with the lighting power densities that are referenced from 2004 values. Typically the spaces that are going to be in the perimeter are going to be a higher space by space lighting power density than those in the core. So you could be oversimplifying it in a way that leads to too little advantage for the project compared against the prototype buildings.
Well, yeah, I just want to point out there's no daylighting in the 2004 baseline at all. But I think one alternative could be that it wasn't required. You could use the building area approach, but then you wouldn't be able to get credit for any lighting controls because it's just
well,
too
the point
variable.
is that the 2004 the 2004 baselines don't have daylighting controls, but the current building is required to, per the mandatory requirements, and so the credit that's associated with that would be undervalued.
Gail, I'm not sure I follow. So when you say the credit would be undervalued, could you elaborate on that, please?
If I understand, and maybe I'm forgetting the 90.1 Appendix G rules, but is the proposed design allowed to model the daylighting as designed?
Correct, yes.
So there is a very high lighting power density associated with the baseline in the perimeter spaces. That lighting power density is going to be reduced in the proposed design, both by the lighting power and further reduced by daylighting controls. There tends to be much more lighting in those perimeter spaces in terms of the lighting power density because of the kinds of spaces that tend to be in the perimeter than in the core. So this simplification may oversimplify for the relative credit that's associated with the daylighting.
Got it. Okay.
I guess this is Scott Sheeter. I kind of, echo what Fred was saying and kind of refer back to some of the simplification thresholds we made for envelope. I guess if we're okay with the whole building being within whatever 20% wall area, then I feel like a building area method gets you easily within 20% of the space by space LPD if you actually add it up and compare. I've done that several times. Usually the space by space method gives you 5% or more or so lighting power allowance. And then, with just all the low level of lighting power and the level of accuracy we're shooting for, it really feels like we should just apply a similar approach here and not require people to do a bunch of area takeoffs to figure out how much area they have of each of these space types.
Right.
That's where I'm at.
Could I mention something? This is Dwayne.
Yeah.
I think almost never see anyone submit a building area lighting power analysis. Everyone does the space by space, as far as I can tell already. That's like the normal way that people process this. And so it seems like that going with the building method would actually end up requiring a different calculation of some kind.
Well, I guess I just counter with the normal approach is done by building energy modelers that are not our intended audience for this. I thought we're trying to get like a simplified approach to a wider audience that aren't, used to doing this.
No, this Fred, I can speak to the whole building, which actually we do use fairly frequently, and it's going to be completely non-relevant to this conversation. Is if you have to fill out lighting power densities for 4,000 spaces in a 1,000,000 square foot building, you choose the whole building method. But that's again not particularly relevant to a building of these scales. So, but if our general approach is simplification, I think it's
the eQuest approach allows you to identify a percentage of each type that is, and I believe it's in a different tab than this, but a percentage of each type that is in perimeter versus core. And I think it probably aligns a little bit better with the actual load distribution and schedules, if you have different schedules for different space types. That's to be better, even in a simplified modeling approach, for modeling variations in HVAC loads, particularly if you are comparing against the high lighting power densities that are associated with 90.1 2004 values. It seems to better account for the varying loads and schedules between spaces that are going to affect performance of the systems, even using the simplified approach.
This is right. I would agree that the benefits aren't necessarily just the lighting power difference. It's more about the other things, the ability to give specific loads and schedules, and the ability to take advantage for lighting controls, which I think there's no way to take advantage for any lighting control savings if we don't go down this path. So it's not about the difference between just the lighting power that you would have from the space by space versus the building area method in the baseline. That's just a small piece of it. The others overwhelm that, I think.
But I probably would recommend adding the eQuest component to the simplified approach. That does allow you to group it to specific spaces if you want, or to identify a percentage perimeter versus core for each area type, to better account for that distribution of loads.
This is Chris Baker. I'm with Willdan. We do simplified energy modeling currently for a number of utility programs. And the simplification of building level areas instead of space type is one of the major time savers of doing a simplified model. Doing that takeoff is, a lot of the time savings is not having to get the exact square footage of every zone in the proper location with the, and what we have found when we've done A/B testing with that is that it doesn't make a huge difference. Now we kind of go a middle ground between these two, where we will do the building level, the building area, but most buildings will have 2, maybe 3 or 4 quote building types in them. And so if it's office, we'd have a building level office, and you wouldn't break the corridor out. But if you had office and library, or office and some other kind of building type difference, and then we also break out labs or other space types that have a substantially different load. Echoing Fred and the other comments, that going to a stiffer requirement than 90.1 specifically seems to be counter to our goal, and just adding to that this is a major time component of the savings. And if you don't allow it, we won't get much of the simplification benefits.
So Chris,
Chris, 90.1 requires space by space for the modeling, and then also for controls when you do section 9 prescriptive requirement.
I'm clearly out of date on 90.1. It's been a while since I've done a model myself.
Right. So Chris, then can NEO account for savings through controls if it's using this building area type approach?
We apply controls by kind of the total areas, and then what percentage of the area have those controls. So yeah, we do schedule multipliers and schedule adjustments to kind of big blocks of the building, depending on which have the controls.
That's exactly how we do it too, okay? Just to reiterate.
And to address controls, as is stated in modern energy codes, there's a lot of them already there. And so typically, those end up being pretty neutral between the baseline and proposed. So using the whole building method, the errors are offset from one another because it's rare that we go above and beyond lighting controls these days. Again, if you're referencing 2016 or later.
Yeah,
but not with the Appendix D approach, right? Because Appendix D, there aren't many controls in the baseline, so it becomes much more important than when you've got a baseline equal to the current code. If we do go down the path of the building area, what it would mean would be that the credit for controls would be much less than you would likely get if you used the space-by-space method. So, for instance, if you had an office wing or something like that, and you had occupancy sensors. I don't remember what the table in G is, but I'm guessing if you had occupancy sensors in the corridors, that's much more impactful than occupancy sensors in an open office area, right? And so you wouldn't be able to distinguish that. So we'd have to come up with some rules that are conservative and give modest amount of credit for different control functions. That would just be the outcome of this decision.
But I mean, isn't that generally our trade-off, that we're going to be a little more conservative on savings claims, get the simplification? That seems reasonable to me.
Right. That's really what
that's the trade-off. Yes.
Yeah.
Yep. I mean, it's a cost-benefit analysis, and something that I always found interesting of my colleagues who do work on smaller buildings, where your annual utility bill is equivalent to the amount of money spent on creating the model. And so the amount of effort that goes into creating a model, it's tens of thousands of dollars potentially, and your whole annual bill is $10,000 or $20,000. So something to consider as we're trying to figure out the cost benefit of this. If we spend $40,000 on an energy model for a building that uses $3 million of energy a year, that's good business. But if we want to convince more people to do more modeling, you need to get these down to the hundreds of dollars to run these models.
One other related piece here is that all these controls are mandatory, so they'll have to document that they have the proper controls in each space anyway, when they do a simplified energy model for compliance with 90.1.
So is there maybe a way to get around that, if focusing on the simplified energy modeling approach, by actually adjusting those 90.1 rules so that we basically compare the average performance, including controls in the prototype buildings for each building type, and develop a building area method that's different for the baseline design, and automatically account for the proposed design controls that are required in terms of schedules and building area method.
So, Gail, to understand what you're suggesting, you're recommending, might have completely misunderstood this, but looking at the prototype buildings to see what kind of space type breakdowns they have to identify what kind of controls might be required?
You're basically just making a building area method that kind of aligns with the prototypes versus the currently referenced values, so that we're essentially recognizing the credit improvement that's accounted for within the building determination of building performance factors, and accounts for controls, and so that those don't even end up getting modeled in the simplified energy model. It's just all accounted for in terms of the methodology.
Right. So then we would come up with the reduction factors by building area type based on what's been modeled in the prototypes.
Right.
You talk about reductions, a schedule change, so you wouldn't want the user to enter what their actual design lighting power is, Gail?
No, they would enter their actual design lighting power for building area method, the same as they do in the building area method currently, but that basically you would define what the building area method reference would be in the baseline, and any adjustments to the schedules that account for controls, or to the proposed lighting power density that account for controls automatically at the building area method, based on the prototype buildings. So for example, if your prototype building is showing an average occupant sensor reduction of 7% across the whole building, because of the mandatory controls, then you.
But that goes against the approach of being conservative, right? That's the approach of being average, right? So because then you're saying that we're going to assume that any building is going to get the average amount of savings from the controls instead of a more conservative assumption.
It goes average, but it is aligning with the building performance factor. So you're still you're still essentially to meet the minimum. You're still apples to apples there.
Right. And Gail, just to clarify.
And if they put in controls in excess of what's required, what happens then?
That's a good
question.
question.
You're basically suggesting we take out the impact of controls, which is what I think I said originally that we might have to do if we went down this path, with the alternative being more conservative.
Right. I mean, most people have already said that in 90% of cases, the lighting power requirements are already so stringent under 90.120, 16, and 2019 that you're not getting a lot of reduction from the controls anyways, so it wouldn't be a big hit.
Right. So how about if we made it, you could do the building area method, and if you do, you can't get credit. You have to put in the mandatory controls, and you can't get credit for anything beyond that. But if you use this approach that Supriya laid out, you then have the ability to get credit for exceeding the controls.
Yeah, that makes sense.
Yeah, it works for me.
Okay.
I agree.
That's great.
The only downside is we don't get those other benefits about the schedules and the loads, but in the ventilation. But I'm not sure how important it is.
Again, I would recommend for the approach Supriya laid out that you would add the extra component there that's currently there in EQUAS to be able to
the perimeter and core space.
Have the choice of identifying what portion to go to the perimeter versus core.
Right. Yeah. Okay.
So you mean just to be able to know the impact of daylighting, Gail?
Daylighting and also to be able to account for loads that are going to vary in spaces in terms of the impact on HVAC.
Right.
Yeah. My thought for if we are implementing daylighting, that you would just identify the percent of each space that's in the primary or secondary daylit zone, and then you would just get the credit for that percentage of the lighting.
Yeah, agreed. Although again, I think that even in a simplified modeling approach, there's a benefit to being able to show actual variations in loads between thermal blocks. And so if you're likely to have lighting power density that is much higher in the perimeter than in the core, particularly in the comparison 95 2004, being able to document that, or having the option to document that, is it could be valuable.
If there's going to be like all these different kind of use cases, like you could go this path or that path, it would be useful. I mean, just understanding that is probably unapproachable for someone that's wants to just get it done pretty quick. So I wouldn't mind there being like a, I've read Appendix G and all the exceptions. It'd be nice if this PRM had like option A, and then option A was like conservative savings and like a page long. This is the quick path. These are the 10 bullets you got to hit, and you can move on. And then option B is whatever, 5 pages long or whatever. And you can dive a little later, but I don't know. I'm just a little worried that we've got all these options and you can do this and that, and someone who's kind of new to all this is just going to pick it up and be like, I'm already done. I don't want to even read this anymore.
Yeah. No,
agreed. Although the simplified rule set is focusing on implementation by simulation developers, and so we're basically providing 3 different options that can be implemented, but the likelihood is that most simulation developers are going to choose 1 or 2, and it's going to be very simple from the user perspective, but more complex to implement from the simulation developer's perspective.
Yeah, I mean, you got to keep in mind. I hear you when it comes to simplification, but when used for code compliance, the details are pretty important, and it's going to have to get past a committee that's really interested in those details, and the building's still going to have to comply with all the mandatory requirements in 90.1, and people are still going to have to go through that and know that, whether they want to or not, if it's being used for code compliance. So it is a challenge. I mean, I think we're trying to make something much more simple than Appendix G is, but it's just not going to end up being able to be, that simple and still be used for code compliance. If we look at a couple of the recent versions of the code, I think we had less than 4% savings between 2013 and 16, maybe, and that's a big deal. The difference between complying with each of those standards. So you think, you might think 4% is not that much, but it is when it comes to energy codes. On the residential side, it was less than 1% in each of the last 2 versions of the code.
I think that's also part of it. If somebody's using this and they take a first pass through the let's call it the simplest version, and they fall short, and then say, okay, well, I can either spend money on doing a more detailed model, which could still be within the simplified realm, or go to a full-blown detailed model to get credit for the things I am doing that aren't covered here, or just spend more money on the building. Either way, that's something that the users are going to have to decide on a project-by-project basis to say, again, what's the cost-benefit of doing A versus B.
And Fred, could you please remind us the tool that you demoed last time?
Yep.
Does that go into the level of details of spaces, or is it more?
Yes.
It does, right?
It does. I mean, and it's designed flexibly. You could do either one. And it's meant to be, again, that you have. This is one of the fun tasks we get for our buildings is before we even have an orientation and massing of a building, we are asked provide energy results. And so all we have is a building program.
Right.
The space types, this many square feet. And then we just, put that in and make assumptions on orientation massing, maybe do some sensitivity studies there, sensitivity on window to wall ratio, and get a result out of it. But ultimately the solutions need to, if you want to have this, be for design assistance, you need to have flexibility. If it's just for compliance, it probably could be a little less flexible.
Right. Right. This actually goes back to something that Andrew Corney's been talking about, that we need to identify the use cases and also who's going to be using this, because all of that impacts the decisions we're making. I see two very clear thoughts emerging where we're talking about code compliance, where this level of detail is something we need to think about. As Mike said, when it goes through the ECB committee, these are the kind of things that are going to come up. But when we look at utility programs, and Chris Baker mentioned this and Scott mentioned this, this level of detail is not something that is desired because you want an approach for doing a quick analysis. And all of this is just adding to the cost if you need to do the space takeoffs, etc. So it's
Yeah, I agree with that. I'm definitely not falling in the arguing for the utility efficiency program simplified approach, just if that's not clear. I don't really do much code compliance modeling. There's already an approach for that, I guess. So I'm just kind of fearful we're going to spend a lot of time creating something that doesn't look that much different than, you know, an ECB Appendix G approach.
Right.
And I think that's something that also needs to be done in, I guess, you know, to call it, for lack of a better term, to market this approach of what are you gaining by doing this? Because we know you're gaining time savings by not doing the full-blown detailed model, but the other side of it is you're getting the flexibility of not strictly following the prescriptive approach since you're doing a model, and I think that needs to be conveyed. I think there was it was an ibpsa survey. Oh, it was this year, I believe. Why do people do energy models? And I believe the dominant answer was flexibility in design.
Right.
And so that's again something that we have to effectively convey here. That the project team gets flexibility and potentially cost savings by doing this.
Right. Right.
But it's got to be, again, still a modest cost and a modest learning curve. Otherwise, people are just not going to bother. Yeah,
and appropriate level of accuracy somehow. Otherwise, right. So, looks like we're talking about two broad approaches. One where the lighting power density is identified at a building area level, and a building could have multiple building area types, like that's what NEO does. And we would need to do some work up front to identify the percentage reductions for the mandatory controls at a building area level. So a user would just get, that's the only credit a user would get, and any control beyond the mandatory minimum is not something this approach would give credit to. The second approach we've been talking about goes a step beyond what's on the screen right now, where in addition to identifying the space types in each building area type, a user would also specify their distribution for perimeter versus core, and then they can take credit for the reductions, for the lighting control reductions, and they can go beyond the mandatory minimum because we know the space by space breakdown. We also get the sense that if this approach is to be used for just utility analysis, utility incentive analysis, then maybe the space level detail is not a requirement. But when we look at code compliance, we do need to look at things in a better, like a more detailed approach. I am not sure on whether we want to allow both in SPRM. The entire idea of SPRM is that it's simple, but if we have an option where a user can go using a building area type versus a space by space type, it looks like we're almost creating an additional SPRM approach. So I am not sure on what to do about that. So any additional thoughts from anyone on this discussion?
Supriya, this is Dwayne. I'm wondering what's the appropriate time? Is it now for me to raise my fundamental objection to this whole approach, or do you want to do that at some other meeting or at some other time?
Right. No, Dwayne, let's go. There's no appropriate time, so let's just do it right now. Yeah, go ahead. You voiced some concerns before, so maybe this group can also help address some of your concerns. So why don't you go ahead?
Okay, it's a song that Supriya and Rosenberg and others have heard me singing many times, but my analysis shows unequivocally that when energy modeling is used for code compliance, the way we do it now, that it always results in a worse performing building. And it results in a worse performing building because it's always used to make a worse building envelope, and because it's used to trade things that people were going to do anyway. You know, nobody ever uses their whole lighting power allowance or their whole fan power allowance, or, you know, uses those inefficient old boilers. And so they're trading, so-called trading these things they were going to do anyway in order to make the building envelope cheaper and worse. That's why owners hire modelers to do modeling for code compliance. So my hope with this simplified thing, now if this actually takes off and it becomes popular and people use it all the time, I'm hoping that this does not also then open the door for a vast number of additional buildings to use this modeling workaround to make the buildings worse.
Right.
I don't disagree with any of that. I guess I'd just say that that's why I guess my focus would be on, you know, a simplified tool approach for design assistance than code compliance, but that's just my own personal bias.
And I don't disagree either, and it's why in my projects I do put a fair bit of pressure on folks designing the envelope, that it does at least break even, especially, you know, not to put too fine a point on this, and I know this is being recorded, but the comment of, okay, you have to beat code by 20%, 30%, and the first thing the architect does is put us in a 10% hole. I basically, you know, in a much, you know, less blunt way, say, hey, you know, you got to help us along here. This isn't, we can't achieve those goals based, well, I'm not saying you can't with HVAC, but, you know, it's much more difficult, especially since the envelope drives peak loads and therefore makes, you know, non-all air solutions less viable and so on. So, yeah, I agree that, you know, the envelope almost always performs, at least on the heating side, worse. We can usually get a better envelope with lower solar heat gain coefficients because they're not that stringent to get the peak cooling load down. But yeah, no, but that's, again, it's not written into the code. It's just something that I do, and so it's a valid concern, and I wish 90.1 would continue to clamp down on envelope performance values, because we can do better, and project teams choose not to.
Those big glass buildings are so pretty, though, Fred.
They're not. I'm disgusted when I look at them.
We have a really good opportunity here.
Go ahead,
I don't know, you guys might not know this, but 90.1 approved an envelope backstop for when you use the performance path. I forget the addendum designator, but it's actually been published. It's out on the website. And it tells you that even if you use the performance path, you can only be a little worse on the overall envelope. You use the 90.1 Appendix C approach in order to document that. It's a pretty loose backstop, but we have the ability with this rule set to make any backstop we want. So for instance, we could say you can't do any worse than a prescriptive envelope, or we could say you can't do any worse than an Appendix C envelope if you want to do worse than prescriptive, which I think is reasonable, because often there's a little tiny piece of your building that can't comply with the prescriptive requirement. We could easily build that into this, and it seems like everybody's kind of in favor, and that would make Dwayne happy, which is always a tough task.
Right.
So
Yeah, it's like one example I can think of is a hospital we finished a couple of years ago in northern Wisconsin, where, you know, 90+% of the envelope, it's a brick building with punched windows, everything is compliant, but it's got a nice entry lobby. It's a big glass box, but that makes up less than 5% of the envelope. You do want to give teams and architects some license for architectural expression and so on. You can't tie their hands entirely, but, you know, that's the kind of what I think we should all be working towards, is give them a little flexibility so they can do, beyond, and there's reasons beyond aesthetics to do it as well. But yeah, by and large, the envelopes need to be performing better, and that's very exciting news that there's a backstop on envelope. I'm gonna have to find that. That might be the coolest thing for 2020.
In Seattle, my proposal for our code that's going to start here shortly was to have that zero tolerance backstop, to just say, no, you can't have it be any worse. And in the final hearings, I got beaten back a ways, but we have now a backstop that the building envelope, when modeling is being used, can't be any more than 10% worse total UA than prescriptive. And so that's a victory, because I think you've seen this with glassy high rises all over the place, that the envelope gets degraded by up to 50% in some cases.
Got it. Okay. So an envelope backstop looks like everybody's in favor of it. And Gail, were you trying to add something as well?
I was saying the exact same thing. So yeah.
Okay, perfect. Okay, so so there are two ways we could go with this. We could have something like what Seattle has, a percentage worse than the prescriptive UA. Go with what Appendix G has, which is, Mike, I believe that's a percentage worse than Appendix C, right? Or is it also prescriptive UA?
No, it uses the Appendix C approach, but we can, I'm guessing that the feedback we might get from this group is that makes it too complicated, right? Right. Even though Appendix C is fairly simple, but I think we could brainstorm some ways, depending on how close we want to make it to the prescriptive, we could just do I don't know, UA is still almost not that much more difficult than Appendix C, so we should give it some thought. Okay. I mean, we could say you have to meet the prescriptive requirements. One of the backstop proposals we had for that I moved for 90.1 Appendix G, originally, one of the reasons we picked the 2004 baseline is I tried to make the backstop 2004, thinking, okay, it's 10 years old, 12 years old, who's going to object to that? But actually, people did object to it. But that might be a reasonable approach, that we just make it a prescriptive backstop at the 2004 level, which really isn't that bad, if we want to avoid them having to do the Appendix C analysis.
Right.
Yeah, I agree. And, if you're giving people flexibility, say, okay, you can't meet my standard requirements, them having to do a little extra work to justify that, I think is fair. So I'm definitely okay with somebody saying, okay, we're going to keep, it's going to cost you a little bit more to fill out the form, but we'll give you a little flexibility for it. I think that's fine. If that makes sense.
Right. So by filling out the form, are you talking about the Appendix C approach?
Yeah, or if we come up with an equivalent, either way, but say, okay, this is what the standard says. If you want to deviate from it, you're going to have to do a little extra work. But again, it's the cost of envelopes and whatnot. Again, I know it's a little bit lame to keep coming back to a cost benefit, but ultimately that's how the world predominantly works. And there's a cost to envelopes, and so if they want to have a lesser performing envelope, then they need to justify its use, and there's cost to creating a justification.
Right. Got it. Okay. Okay, this is good. This is actually a good discussion. Dwayne, do you feel better?
Well, I hate to give up my reputation of being a crank all the time.
So you do feel better, but you're not going to admit it. So right. That's good. Yeah. Okay.
We'll find a softball to throw you later on, Dwayne.
Thanks.
The other thing which I feel is a big decision to make is what all of you have been recommending. This rule set for design assistance versus code compliance. You see more value in developing this for design assistance. This is something I think we'll have to discuss internally at PNNL. If we follow that approach, then a lot of things that we've been talking about, the space level detail, that might not be such a huge concern. I do not know what that means long term for the adoption of something like this, and also what kind of medium this gets published in, because previously we were thinking we would go through the ASHRAE consensus process, get this incorporated into 90.1. But yeah, we'll discuss that internally and then maybe update all of you on the path forward. But in general, I think we do agree with the fact that there needs to be lighting input at a building area level. And if there is a space level lighting input, then there has to be an optional path within this SPRM approach and not a requirement. Any more discussion on this topic?
None for me.
Perfect.
Now it's technical easy HVAC, right?
Piece of cake.
That's actually not too bad. Let's just quickly go through controls. So we've mostly covered it. HVAC is actually easy. Well, famous last words, but let's see. Daylighting controls. We discussed this last time when we were talking about fenestration area. Fred, you mentioned that the savings to daylighting now is pretty minimal because lighting power density is so low at this point of time. And for simple buildings, you don't see people exceeding mandatory requirements. So we said that at that point of time, we discussed that the daylighting controls would be based on the user would need to tell us the daylit area. And we would, Gail recommended developing some standard savings factor based on the building area type that could be applied to a building based on the daylit area. Does that ring a bell to everyone? Does everyone still feel like that's a good approach?
I do.
Yeah, I think that'll work.
Okay. Then for occupancy controls, we had previously thought we would use the adjustment factors that are based on the space type breakdown. Now that we already discussed this, we would need to develop these adjustment factors for each building area type based on what the prototype buildings have, which we can do. And programmable controls, this is, again, we would probably need to ask the user what percentage of their building area type has programmable controls. And then we can model this by adjusting the lighting schedule. Now, again, for each of these controls, there are two ways we can do it. We can incorporate them through, we can model them through an adjustment to the schedule. And Chris Baker told us that NEO does that. Or we can model them through an adjustment of the lighting power density. Of course, adjustment to lighting power density is easy for a tool to implement, but adjustment to a schedule is more accurate and maybe not that much more complicated for a tool to implement. So are there any, like what does Ripple do? And Fred, what does your tool do in terms of adjustments for controls? Is it a schedule or a lighting power density adjustment?
We'll do both depending on what exactly, I mean, so like for daylighting controls, it's obviously based on the daylighting. For OC controls, usually we just take a percentage off the LPD. As you know, again, for two reasons, and I mean, again, not so applicable to this scope of work here, is our buildings are large. You know, the total lighting energy is 2% of the building's total energy, if that.
Right.
And so getting hyper accurate on something that will probably make less than 1% difference, or less than a fraction of a percent difference, we tend to just do the simpler approach.
But that's because you're working on mostly hospitals and labs where lighting is a smaller fraction.
Right, or just buildings that are generally larger as well and come with more other interesting process usages and so on. So it's, I'm sure my experience is that relevant for what we're talking about right now.
So Fred, I'm sorry, you said you suggested that a schedule adjustment for daylighting, but a lighting power adjustment for other lighting controls?
No, so there's a, I guess it would be I guess what's Energy Plus doing internally is probably an LPD adjustment based on the, it's happening at a scheduled time based on what the daylight is to the space. So it's probably, in the way daylighting, I imagine, is handled in Energy Plus is actually doing both. It's taking, depending on what the incident daylight is on the space, and its calculated reduction in foot candles needed will reduce the LPD for that hour, or that time step, whatever that, if it's sub-hourly time step, by a certain percentage. If we're just doing occupancy controls,
well, hang on, that's not a simplified approach for daylighting. That's actual doing a daylighting
right, no, I mean, that's what's baked
right?
into the model, because it's what's available in Energy Plus. Now, we don't necessarily always, again, not every space has daylighting controls. So I mean, it's just using what's available is baked into Energy Plus. And sometimes, again, if we're early on in the modeling process, we just ignore it. To be honest, again, because you're taking a percentage off of a small number. If you're, again, we're talking design assist versus compliance here. If we're early design assist here, we will probably just ignore daylighting controls, unless it's something like an atrium or something where daylighting is going to be very pronounced as an impact. But otherwise, for example, you have a patient room, they don't have daylighting controls. Even though they're on the perimeter, because you'll impact medical function. Lab spaces tend to not have daylighting controls unless they're unoccupied. But then the aux sensors will probably turn it off anyway. So stairwells can't have daylighting controls very effectively because of egress concerns. So a lot of the perimeter spaces that I have to deal with on a day-to-day basis don't get a huge impact from this. Again, more typical building types that you all work on probably would benefit more from a better, more sophisticated daylighting control approach. So similarly, whereas we'll spend 10 times as much time on getting the HVAC just right, because if it's off by 1 or 2%, that's 10 times what the lighting impact is. So, gotta pick your battles.
Right.
But yeah, aux sensor controls are usually just an LPD reduction. So, and again, they're usually these days neutral between the baseline I proposed. For by and large, the most part.
Shanta, maybe you could provide a little more context. I'm assuming you work on more diverse building types and on several design assistance projects. Do you usually look at daylighting controls or occupancy controls as well through at an early stage of design through just an LPD reduction?
Yeah, we do. Yeah, we definitely. Usually early on in design, the lighting designer hasn't really started because they're kind of waiting for the building to settle out, but we make assumptions starting right away that all of those components for a lighting system to save energy would be included in the project. And sometimes maybe it's just an estimate at the beginning, but it just kind of also makes sure that it gets into the pricing. And that's probably the most important thing, is that we just want the money to be there in the budget for later on. Right, makes sense. And I think that most folks know that there's a payback for lighting controls and good lighting equipment, most of all. I should put a caveat, though, that most of the projects we work on are kind of higher end, I would say. So they tend to have a bit of a more generous budget to start with. So projects that have more limited budgets, and we bring in like a utility incentive program early as possible to help make sure that they can get the controls, especially if it's a design assist kind of project or developer driven project, or they just have like a very fixed limited budget.
That's a great point, Shanta, and it's also part of it is just making project teams aware that these are the expectations. Lots of folks don't keep up on the latest energy code. Actually, the vast majority of people don't keep up on the latest energy code, and they say, "Hey, I just permitted a building last week. This next one should be just fine." we're going to permit in a year, and then I can give you an example for in the state of Kentucky where we had done phase 1 of a project. I think it was like under the 90.1 2007, and then phase 2 dragged on a little bit, and phase 2 ended up having it delivered under 2013, but the design didn't change. Mm-hmm. And people didn't realize, and we joined the project and said, no, sorry, you have to change all these things, and that's where energy modeling again came in quite effective, where we're able to do trade-offs and show, okay, where can we make investments to make the building comply. But that was, that energy codes change over time is a surprise to a lot of people, unfortunately. And so, getting the information out up front, letting people know, like, the expectation is that you have daylighting controls for all these spaces.
Right.
And you have these controls in place, and, I don't want to say the budget be damned, but it is the expectation. So
we have to have like a simplified code to go along with this simplified modeling rule set.
It's effectively what ComCheck is, right?
Okay.
But again, that requires somebody to read it, which I don't think we have a tool to make people do that yet.
Everyone should be geeks like us.
Yeah. Sure, that would introduce all sorts of other problems then.
Okay.
So, yeah, anyway, sorry, getting off tangent here. My fault.
No worries. Basically, if there is a simple way to analyze these controls, then it makes sense to include them. Else, either the savings is so low, or usually the budget is so low that you do not end up analyzing daylighting controls or occupancy controls for smaller projects, right? That's what I'm getting from the team.
I think the nuance there is that you need to have some quick way of throwing a number on the board so that people realize that they're there and they're required, or they should be considered. But that the trade-off of time isn't really worth it. You just need to get a value and the ability to change that value. And then that captures the value. Those are two different values. I'm sorry, I used the same word twice.
Right, got the point. Okay. Great. And Chris Baker, just to ask you the same question as well, because you'd mentioned this, do you see a lot of relevance of controls, lighting controls in the buildings that you analyze for utility programs through NEO?
We're still claiming some savings. It's not a huge amount of the savings anymore. Yeah, I mean, people still pick them. It tends to be low payback things, and so it helps the overall economics of the building, but it's not a huge contributor.
Okay. Okay. That just
lighting, power, and controls together is about 1/3 of the savings on average across our programs.
Could you repeat that? Controls and what together?
Controls and lighting power density are about 1/3 of the savings overall on average.
Significant, yeah.
But then I just add that usually the lighting power savings is 2/3 of that, if not more.
Okay.
Yeah, probably. Yep.
Okay, perfect. That's helpful. So, okay, this is helpful, and this will provide us some guidance on the amount of effort or the level of detail we require for modeling controls. Any additional thoughts before we move on to HVAC? Okay, so let's start with the baseline. I thought this would be more straightforward. So when we developed the applicability criteria, we said that the SPRM would not apply to multi-zone systems, and it would not apply to central plants, specifically chilled water plants. So eliminating all of those system types, we are left with these 6 system types for the baseline. So for the baseline then, following the Appendix G approach, for the residential, all building sizes, we have PTACs and PTHPs depending on climate zone. For all other buildings, we have single zone systems, rooftop gas furnaces, and heat pumps based on climate zone. And then there is the requirement for heated only spaces, heated only storage in Appendix G, which has heated only systems 9 and 10 with gas and electric resistance heating. So those are the only baseline system types that we are left with for this approach. Again, we also do not have any restrictions on building size or number of floors, but most of our other restrictions should take away most complex large buildings or tall buildings, because tall buildings are likely to not be single zone systems. So I feel like the fact that we don't have a system that can apply to a high rise in the baseline might not be such a huge concern, because a proposed building might not qualify for SPRM. But any first thoughts on the way the baseline system layout has been configured?
This is Chris. I guess I might have missed it in an earlier meeting. I didn't realize we were only allowing single zone systems.
That's right, Chris. Yeah, we discussed that, I believe, in the second meeting. We decided that we would not allow buildings with multi-zone systems for this approach, because then they have reheat and they have additional controls, which cannot be very accurately analyzed with the simplified geometry and simplified thermal zoning that we're going with.
Has there been any comparison of models to look at that, or is that just a people's professional opinion?
Right. So no, we haven't done anything yet aside from what we had done a long time ago when we looked at NEO and asset score. But I think the discussion at that time was that when we discussed it within this group, it was good to start with something simple just to get this through ECB the first time. And as we do more analysis and once this gets approved, then we can add more the multi-zone systems or even central plants if we want to. But as a starting point, we were keeping it simple. But no, to answer your question, we haven't done any analysis to see how the impact on energy use of simplifications on multi-zone systems.
Okay. I personally think it's overly conservative. That might just be, I mean, so we are doing district, we are doing boilers, chillers, and VAV systems and other multi-zone systems. I don't, off the top of my head, know what the comparison is. I know when we compared zone by zone zoning versus the zoning algorithm, we were in a couple of percentage difference in savings percentages only. So it was pretty close, but I don't know, I don't have that broken out by VAV versus single zone.
I'm trying to remember what the threshold was for package single zone in the baseline. I thought it was 25,000 square feet. It might be higher. Where, you know, anything that's larger than 25,000 square feet needs to go VAV anyway. Maybe somebody has that handy. What that square footage threshold was. So, I mean,
okay, let's see. I missed it.
Yeah, I thought earlier when they indicated that that was overly restrictive because of that 25,000 square foot limit.
Understood. I'm just worried that we're creating a conflict here by saying you can use this for any size building,
right,
but your system has to be this. But, you know, I guess the question I have to really, I guess I've never looked. Can you make 100,000 square foot building with all packaged single zone systems? You know,
right. It's challenging, and
definitely, it's not that uncommon.
Okay, so
I mean, big box retail for sure, big warehouses, but
right.
offices, I don't know.
True.
I haven't seen that.
right.
But in the baseline, there's limited applications where you could.
Yeah, I guess that's
right. So
point. Yeah, if your baseline
I guess
would ordinarily be VAV.
We wouldn't expect to get many 100,000 square foot offices, right? But we don't necessarily need to write them out, I guess would be the approach. But we wouldn't expect that we would get many.
Well, even a 5-story residential application, even if they only have 3 units per floor, would technically have a requirement, the way the rules are written, for a VAV system for the corridors. They're still single zone systems, but you're running into simplifications because of the way the rules are written that are overly restrictive for simple buildings.
Well, question for you, Mike. I'm picturing suburban, office park developments where everything is 3 or 4 stories, but sometimes the buildings are quite large and they have a little village of rooftop units on them. Are you thinking that would not be using this simplified method?
No, it could, according to the rules that we've been writing, right? So we're not limiting it. We're not placing a size limit on it just for reasons like that, because it's really about the complexity of the system more than the size of the building.
So we very well might get 100,000 square foot things in suburban applications. You probably don't get them in cities.
Yeah, absolutely. And right, so and the idea would be in that case, Dwayne, to allow those kind of buildings, because how is it more complex than a small 5,000 square foot single story office building in that case, right? If it's just a long rectangular building with perimeter and core and then just 15, 20 rooftop units, it's simple enough to be analyzed with this approach. It doesn't need to go through the detailed Appendix G.
Right. It's got 20 zones, but they're all single zones, right?
Right. Yeah.
Well, and that's what I'm looking at right now. Is I'm looking at actually chapter 11 rather than that. So we're the way that the systems there are set up is I'm in 2016 and 2019 because I don't have a copy handy, but the system maps those the rooftop units. It's an air-cooled condensing source. I mean, either I'm just going to pick electric resistance or fossil fueled. The base system for a commercial building ends up as a packaged VAV in both cases. If I'm reading this correctly.
That doesn't sound right, but.
Right, and that's what I'm a little confused about. It's like, so condenser sources, air or non, that takes you to a heating classification. So say we pick fossil fuel, and then that takes, and then we go to non-residential. I guess. Oh yeah, there. See, I misread that. There's a residential. There's a single zone non-residential. So that's system 11. So there, yeah, you can have, that last. So there's a non.
Still a single zone.
If you go up in the table, the box says non and residential in different lines. So that's what threw me off. Yeah, so you can with the you can build yourself a system 11, which is going to be that package single zone solution then for that. So yeah, I mean, I guess that's the pathway you have to follow then to say I have a whole bunch of single zones in my building, and that's okay then. All right, so we're not creating. I guess we're not creating a conflict then. Okay.
Would it be acceptable to expand the rules if we use this option so that a baseline could replace system type 7 or 8 with all right, not a system type 5 or 6 with system, I'm sorry, I'm looking at the wrong screen. Basically replace a VAV, multiple zone VAV system with a single zone VAV system for every zone. I did some analysis. That's actually what the baseline reference is in India's ECB code. And I did some analysis in the climate zones that are representative in India, and typically that accounted for about a 8% difference in performance versus the ASHRAE 90.1 2010 rules for a VAV system, a multiple zone VAV system. And so that would be a very conservative estimate, but would open up the door for some of those spaces that are just over that 25,000 square feet threshold, or that kind of thing, and want to go through the simplified approach to still use it without being forced to go through the whole.
I think I'm going to rephrase what you just said, Gail, because I think you're onto something. If you are greater than 25,000 square feet and you're using package single zone and you're proposed in the baseline's package single zone, and you're restricted there. If you're less than 25,000 square feet and your baseline is package single zone, but your building chooses to do VAV, I think you should be able to take credit for that and say, okay, I can come up with a percentage threshold there to say, okay, maybe the model will spit out a package single zone, but I get a X% allowance because I have a VAV system and not a constant volume system in my proposed. Because I guess I feel like we're penalizing people a little bit for doing something better.
So what if we did what Gail was recommending only for this threshold greater than 25,000 square feet, and we have the single zone VAV?
Yep.
Not for the smaller one. In the smaller one, you get credit for doing something you're not required to.
Right.
The smaller one could still be CAV.
Yep.
Remember, it really doesn't matter too much what the baseline is. It's about what's used to create the building performance factors, right?
Right.
So it's regardless of what the baseline is. If we feel that for buildings larger than 25,000 square feet, well, we could have a different building performance factor that assumed that there was a single zone VAV system in it.
Is that, Fred, is that VAV, or Gail, maybe is the VAV system you're envisioning like a package DX cooling with like?
Right.
Yeah.
That's what I'm thinking, yeah.
Okay, is that gas fired or boiler or heat pump, I guess, depending?
All of the above.
Would have the same electric requirement as the system 3 or 4, probably. Yeah.
Right. So like.
Got it.
Sorry, the same heating requirement as system 3 or 4.
Based on the climate zone, it would be single zone VAV with gas furnace for climate zones 3B, 3C, 4 to 8, and then single zone VAV heat pump, DX heat pump for 0 to 3A. But again, that's go ahead.
I question the need to do that because it's really all about the target system that we create to BPF. If there is something good about sticking to the same rules as the Appendix G baseline as much as we can. For instance, let's say some software wants to include both the simplified approach and the whole Appendix G approach. It would be much more simpler. The whole idea with the Appendix G approach and this approach is the baseline is really not important anymore. It's about a target system that we use to create. It's about a target system that we use to create the BPFs or the targets themselves. Right, so I'm thinking that the benefit in keeping it exactly the same as Appendix G outweighs any benefit of making a change like this, as long as we account for that in the target that the buildings over 25,000 square feet should have a variable air volume single zone system. And I think that's a prescriptive requirement anyway. I think it used to be a mandatory, but I think now it's prescriptive. Maybe it's still mandatory. I'm not even sure.
Mike,
I think greater than 65,000 BTUs per hour, it has to be a variable VAV system.
In Appendix G right now, there is just one set of building performance factors for office. Could you please remind me, is that building performance factor an average of small, medium, and large office, which has these different size thresholds and system types?
It is.
Got it. So that's what we could do then. We could have two sets of building performance factors, one for a small single zone CAV and then for a single zone VAV, and then the building performance factor could be an average of that.
Yeah. Well, or we can do it any way we want. So I think probably the best way to do it is to see what the building performance factors are for all the different building types and then figure out where it makes sense to collapse them. I mean, that's just a decision about simplification. You know, like 189.1, they decided to use a single, instead of having a different building performance factor for every climate zone, they have one for each building type that applies to all the climate zones. You know, originally in 90.1 Appendix G, we had one building performance factor for all buildings in all climate zones. And then we looked at, you know, that was the simplest approach. The most complicated approach was a different one for every building type and climate zone. And we ended kind of in the middle where we collapsed the building types and kept the climate zones. Even though it probably didn't make sense to keep the climate zones from the amount of spread, it's just what we could get the most people in the room to raise their hands on about, you know, to agree to, which is about how a lot of these decisions get made.
So, Mike, I'm not sure I'm understanding your proposal. We're still limiting the baseline model for the simplified approach to single zone systems, but then somehow we're allowing systems above 25,000 or buildings above 25,000 square feet to be represented with a different building performance factor. What's the recommended approach?
Right. So yeah, what Mike was recommending was exactly that, Gail. The baseline would be what you see, but the building performance factor that has been developed would have a different system in the baseline. Would be using a different system.
No.
Yeah. Go ahead, Mike.
The target system would be different. The baseline is right.
Yeah, target would be the same. Sorry, the target would have the single zone VAV. So basically, when we develop the simplified building performance factor, there would be, let's say, a small office and a medium office, where the small office is the single zone CAV system, and the medium office is a single zone VAV system, and they would have different building performance factors. So, and we can see what those performance factors are like, and then we can either choose to collapse them into a single office building performance factor, or we can have two separate sets of building performance factor, where if a building is greater than 25,000 square feet, they need to use that building performance factor that has been derived using a single zone VAV. So the advantage of that is you have the same standard set of baselines, but the performance is driven by this target system.
Right, right. So, Mike, that would still vary from this approach versus the Appendix G approach for.
But the baseline wouldn't. That's the point, right? The baseline wouldn't vary.
But then the simplified modeling approach, you're still stuck with this issue of the baseline not being a single zone system. I'm sorry, I'm still I'm struggling to understand.
Right.
So let's say the baseline, you had a 50,000 square foot office, and you've designed it with a bunch of well, forget about how you designed it. We would create a building performance factor for a 50,000 square foot office that assumed there were single zone systems in it that were variable air volume. And we would compare that to the baseline, and it would have all the other improvements like the efficiency and everything else that's in a current, prescriptive 50,000 square foot office building, and it would have that HVAC system, and you would compare that to the baseline and come up with building performance factors. If somebody designed exactly that building, then they would just meet the code. If they tried to put in that same building with constant volume systems, they wouldn't reach, the target that's created by the building performance factor, and they wouldn't comply, right? If they did something even better, whatever that is, they went down to a lower minimum airflow or something like that, they would then exceed the minimum requirements.
Right. So what would be the baseline model that's actually used for the simplified approach?
What you see right in front of you. So I think maybe sometimes it's a question of nomenclature. And we're doing this with 90.1 in a different area for HVAC systems, and the nomenclature that we coalesced around is that the baseline system is what you're looking at in front of you, and then I think we called it the target system, Supriya, or did we call it the reference system? The target system. So the system that you decide is the good standard code compliant system now is a target system. And that's what you use to create, and that would have the variable air volume system. So I guess there's always that confusion when you go with this stable baseline. It gets a little bit confusing about the baseline and what the current code compliant building is. And calling that the target is probably a good thing to do.
I want to make sure everybody kind of followed what Mike was suggesting. So the baseline is just like a stable baseline. It's something that we're using to compare or quantify the proposed building's performance. But eventually what's being used to determine compliance is the building performance factor. And what Mike is recommending is using the single zone VAV to develop that building performance factor for the building greater than 25,000 square foot, which kind of makes more sense because then your baseline tends to follow what Appendix G has. Any tool that is implementing Appendix G or is being used for Appendix G could then very easily implement this simplified approach. And in addition to that, through the building performance factor, that's how you drive a building's performance because that's what a building needs to meet or do better than. So having the single zone VAV there instead would be a better approach, as that's what the proposed building would need to do better than to comply with SPRM. Not hearing any comments, so either everybody really agrees or they don't follow this at all.
To be honest, I think I have to just mull it over for a while.
Okay.
It might be actually helpful to see it in writing and
Got it.
think through some examples.
Okay.
And run some scenarios and just see if there's anything that trips it up.
Right. Okay. Yeah, the target system thing, it takes a bit of a while to wrap your head around. And you're right, Fred, having some analysis done in which you see how the building performance factors are calculated and how that compares to the baseline, that really helps. So yeah, I'll make a note of this. We can run this scenario for a few different targets, maybe also just show how the factor is being calculated. And then we should actually talk about this because we don't have any future stakeholder meetings, but it would be good to share all of this additional analysis with all of you. So towards the end of the meeting, we'll think about ways in which, how we can still stay connected to share the results of the validation runs, etc. Okay, we have just about 30 minutes left. I do want to cover a few more things on HVAC. Are there any more thoughts on the baseline systems aside from this one point about what to do about larger buildings? Okay, we didn't get into the entire heated only discussion, but I'll leave that for the end if we have some time. Let's talk about the proposed building HVAC system. So with all of the simplifications that we've spoken about with the acceptable variation for building geometry, using the building area types for the internal loads, schedules, the space type definitions, all of that really simplifies the energy model. So for simplifying the HVAC system for the proposed building, we think there are just a couple of things that are required. In most of the Appendix G guidelines for the proposed HVAC system can be followed. And Appendix G doesn't have too many of them. The only ones that Appendix G does have is relates to the fan operation, where it says that the fan should be the fan shall operate continuously when the space is occupied, and it should cycle to meet loads when the space is unoccupied. And it also says that there are some things about that the conditioned spaces shall be modeled as both heated and cooled. So we can follow the Appendix G approach with regards to HVAC systems for the proposed building, and also allow a user to analyze system controls like DCV, economizer, ERV for the proposed building. So there are no limits for what applies for the proposed building. The places where SPRM would deviate from Appendix G, first, equipment capacity. Because we're using prescribed loads and schedules, we cannot allow a user to specify their capacity, or even if they specify it, we cannot use that in the energy model, because the actual HVAC system capacities based on the prescribed loads and schedules would be different. So we would require any tool that implements this approach to auto-size the equipment. And we can also have the same oversizing factors for heating and cooling capacities as Appendix G has for the baseline. And again, for the sizing runs where Appendix G specifies how the design day schedules need to be defined. So that's the two places, those are the only two places where we would deviate from Appendix G. And again, ventilation rates, Appendix G says this should be as designed, but this would also be something that's prescribed based on the values in Appendix C based on building area type, and the user will not be able to modify this. The only time where this can be different is when a system has DCV control, in which case it gets adjusted for the occupant density or just CO2 sensors, whichever way we want to allow that.
And Supriya, will that just be a straight percentage reduction, or will it actually be some kind of calculation for the DCV?
Right, so that's something we should talk about. It depends on what tools can support. So firstly, there has to be some way for a user to identify what % of the thermal block has DCV control. We cannot apply DCV control to 100% of the block because it's likely that just a small percentage of it, which is meeting rooms or classrooms in the case of a school, have DCV control. So there needs to be a way for a user to identify that. And then secondly, how do tools model DCV control? So Chris, I know that Neo has DCV control, and Scott, I don't remember if Ripple has a capability to model DCV, but how are you guys modeling it? Is it just a small percentage reduction to the ventilation requirements by to the ventilation requirements?
We adjust the ventilation schedule based on what the ventilation requirements for occupants are, and then the occupancy schedule. Okay. And we have a factor that adjusts it for different space types, depending on how often we think that it's unoccupied, either unoccupied or lower occupation rates.
Chris, you're cutting out. We can't really hear you.
Sorry.
Okay. So what I did hear is, Mike, go ahead.
This is another area where by not doing the space by space breakdown, it's probably going to limit the amount of savings that we're able to take for it. You know, if you have a school maybe with DCV, we'll get some pretty significant savings because we're going to probably make some assumption that most of the school area type are classrooms or something like that. But if you had, let's say, an office and you said what percentage of it had DCV, the reality is it's probably going to be conference rooms or classrooms or the break rooms, things like that. But that's, you know, we won't know how much of that exists. So it's going to have to be a pretty darn conservative assumption.
Right, right. And maybe we need to do something like what Gail recommended for lighting controls, where we can either ask a user what percentage of their thermal block has DCV control, or we can develop our own adjustment factors based on what the prototype buildings have for different building area types. Which
Let's
again,
yeah, say actually do both, where there's a default based on the prototype buildings, but then I guess let people just it's the slider bar in a tool. Say what percentage of your building has DCV, and you enter a percentage to adjust from that. So.
And then you'd also have another slider bar that said what percentage of operating hours is that DCV going to be in effect? When is it fully occupied? And because I'm thinking of a school auditorium, that's going to be occupied 5% of the time, right. Whereas the classroom will get occupied, 60 or 70% of the time.
I think we'd want to make it based on the assumptions that we have for the occupancy schedule, but maybe just like lighting controls, that there's an option for using the space breakdown, like we had offered for lighting controls, if they want to take advantage of DCV, and maybe there's other things too. I can't think of any offhand, but they might come up based on space-specific controls.
Right.
Since that's already an option.
Right.
It's another reason why somebody might want to implement that.
Right.
Apologies if this was previously addressed, but I'm just realizing the single zone limitation referenced earlier, does that apply also to dedicated outside air systems? And is there any allowance for those within the simplified approach? Because that seems like, you might have single zone systems in many applications, but you're going to have dedicated outside air for a lot of those.
Right, right. Now, Gail, I think maybe we need to clarify that multi-zone systems with reheat would be the restriction, which would allow DOAS systems which are serving multiple zones to qualify.
That didn't make sense just now because lots of DOAS systems do have reheat.
You mean they have
reheat?
Zone level reheat. I mean, not always
Not
are
in Washington State.
True. It depends on what climate you're in. You guys get away with murder compared to what we were able to do with our climate.
Well, probably, but we just have really strict rules.
Right. No, understood, but it's also, the climate allows for it where you're not needing to substantially dehumidify.
Yeah.
And zone level, it's not essential reheat, so it's not dehumidification and then reheating. It's actually at the zone.
It can be, yeah. Where we'll need to dehumidify a little bit more, and then so for example, take a 4-pipe chill beam as a good example where you it's a dedicated outside air system, but you're using it as your zone level heat source, and again, depending on the building design, how low, A, how low can you dehumidify to, and B, how close to neutral air can you deliver, and that'll vary again based on building type and climate.
90.1 doesn't let you deliver neutral air from a DOAS system.
Yeah, but I don't think the simplified energy modeling approach allows hydronic systems, does it?
No.
Right. That's why
Right. So just to come back to Gail's question. So Gail, you said that multi-zone DOAS systems, again, I'm not very familiar, Fred, with multi-zone DOAS systems that have reheat. I've never analyzed one as such. With central heat, yes, what Mike described with dehumidification and then reheat at the central level. So just based on what you know about these systems, is this something we need to look into for SPRM? Do you think they are simple enough? They can be accurately modeled with the SPRM approach that we've been talking about?
I think if we don't allow DOS for SPRM, then SPRM will fail because it's just not going to be applicable to enough project types.
Right. And Gail, you're specifically talking about we need to include multi-zone DOS with reheat for SPRM, right?
I'm not. I mean, you're going to have your zone systems, and then the DOS system is going to provide temperature. So I don't know whether you would call that reheat or not. But your zone systems are your single zone systems, and the DOS is providing the fresh air.
Right. I mean, I guess, if you have thermodynamically a hydronic chilled beam with 4-pipe hydronic chilled beam with heating and cooling is not any really different than a DOS feeding, a fan coil or another DX unit that's providing the local heating and cooling. I mean, you're still delivering conditioned outside air to a space and then further tempering it, whether that's adding heat or in some cases adding more cooling. It's just the mechanism of how that heat is provided, whether it be hydronic, electric, DX, etc.
Right, but the controls are different, right? I mean,
true.
It's a control.
I think it's a question of how complicated we can get with the controls. But there's something else important to keep in mind that maybe should be brought up, and that is, when we've had discussions with the 90.1 committee about the SPRM approach, there are some that are opposed to having a choice, right? So what it seems like the consensus is that a building would either qualify, and if they're going to do the performance path, they wouldn't get to do, if they qualified for the SPRM, that's what they would have to do. If they didn't, they would have to do Appendix G. They don't like what's called path shopping, right? Because then people inevitably choose the less stringent path. So that's one of the reasons to keep more complicated systems out of this path. Not that I think a DOAS serving multiple zones is too complicated. I think that's probably appropriate, but I just wanted to bring that up.
I do think that the path shopping approach is worthwhile in this instance, because the reason for the path shopping isn't the stringency, but the level of effort commensurate with the benefit achieved from design phase modeling.
Yeah, it's just a question of whether or not we'll be able to get something like that through the committee. I'm just pointing out that that's something they've been pretty aligned about, most of the members when we've been discussing this. It should be one or the other.
And Mike, maybe one way I was thinking, just based on what everybody has been saying so far, if SPRM, so Appendix G started off as an approach for beyond code programs. It wasn't even an option for code compliance until recently. And one way to deal with this would be to have SPRM as only an approach for beyond code programs, design assistance programs, and not even be an option for code compliance in the first round. That way it would be an easier thing to get through the committee. And we could also have these kind of options which the committee would not want for a code compliance path.
Certainly that's possible, but then you've really, really cut down on the usefulness of it for sure. Yeah. I would hope we don't have to go there, but it's a good backup, I would say.
Right.
Mike, is there any precedent for putting an appendix in or something that's not intended for code compliance at all?
Yeah, that's the way Appendix G was. You make it an informative appendix, right, and it can't be used for compliance. That's how Appendix G was until halfway between 2013 and 2016.
Okay.
Yeah, Dwayne, that's the this people don't take up radical ideas. Not that this is radical overnight, but having something grow on them, and then the usefulness is proven over time. That kind of carves a path for adoption of these kind of approaches. So.
No, ASHRAE doesn't take up radical ideas. We do all the time.
Yeah. You guys took up TSPR. ASHRAE takes a while. Okay, we just have about 10 minutes on this approach. So just to summarize, Gail, we will add an exception for DOAS systems. So where we say in the applicability criteria that multi-zone systems cannot be analyzed, we'll say except DOAS. We'll add an exception for DOAS systems over there. And for DCV, looks like we want to have the same thing that we discussed for lighting controls, where we identify the percentage of ventilation rate reduction based on building area types, which can be used for the building area type approach. And when a user specifies the space by space breakdown, then we can model the actual ventilation rates and adjust that for DCV control. So any other thoughts before we move on?
Hi, Shanta. I just have a quick question. I just wanted to clarify. Did you say that for the SPRM, you couldn't have something like a perimeter heating baseboard in the cold climate?
No, I don't think so, Shanta. Unless I'm forgetting something, we only restrict, well, yeah, we only restrict multi-zone with reheat systems, and for hydronic, we only restrict chilled water systems. We decided to include hot water systems. So if the perimeter baseboard was a hot water or even an electric resistance baseboard, it could be analyzed for SPRM.
Okay, thank you. I was confused about that.
Right, no, that's good.
Thanks
it's
so
good
much.
to clarify. Okay, so renewable energy systems. So this is, again, hopefully this is straightforward. For renewables, we were thinking we would follow the PRM approach, where renewable energy systems are not modeled for the baseline. But in the proposed building, if renewables are present, they can be modeled. Appendix G does limit the renewable energy credit for the proposed building, which is a maximum of 5% of the baseline energy cost. So the two questions are, A, should we support, should SPRM allow renewable energy systems to be modeled for the proposed, which also begs a question on, do simplified energy modeling tools support modeling of PVs? And we have an additional option where we can provide some simplified modeling guidelines for PVs within the rule set. Is that something we should consider including?
Shanta here. I think that, one thing to consider is that for folks that are putting PVs on their building, they would be really happy to get some kind of recognition and credit for it.
Right.
And if they were doing that and they weren't allowed to include it, I imagine they'd be pretty disappointed.
Yeah, and they might not even have that motivation in that case, right?
But
yeah.
I think we need to clarify something. It's not that Appendix G only allows you 5% credit for renewables. It allows an unlimited amount of credit for renewables. What it does is it requires you to meet the minimum compliance with only 5% of the baseline in renewables first. And then also, then you get as much, towards your performance cost index, clearly, designed that way so that you could reach a net zero building. So that's an important distinction. And really the purpose of the 5% is the same purpose as the envelope backstop. It's so that people aren't trading off mostly the envelope or any other long life measure for just putting on PV. So if we go with so we could do what Appendix G does and have that two-tiered approach if we're going to include renewables at all, which I think we should if possible. And then, but if we do go with the stringent backstop approach, we don't even have to worry about that 5% issue at all.
And I just add that what rooftop PV is kind of trivial in comparison with like HVAC efficiency or window area, but it's very popular. People get excited and happy about it. And so if you want to sell this SPRM thing, make sure you can get some credit for rooftop PV.
Yeah, I agree. It should be included. And as far as including it in the tools, something that's, I've been going through in the back of my mind here for a couple of different things is exceptional calculations. As far as I know, and others can, tool developers can chime in here, they typically don't include a PV modeling tool. There's standalone PV modeling tools that work just fine, right. And it's not really. Yes, you could account for the shading on the roof and so on, but that's well past the point of simplification anymore. It's just a straight deduction of this. PV system generates X kWh, and I just lop that off from the bottom line of my proposed model. So there isn't a ton of interaction, at least not for PV. Solar thermal, on the other hand, will have a interaction with either the service hot water or the heating hot water system. But again, now we're getting into the complexities here that we're to be avoiding. So I think you just have a placeholder for somebody to be able to put a line item, say this is what my PV system generated, and attach an output report from your favorite PV modeling tool or whatever renewable modeling tool you want to use, and move on. But I guess it's a question that we should be clear about as far as exceptional calculations, yes or no, and if yes, to what extent.
Right. That's a great point, Fred. There is limited interaction of PV with other building loads or other building systems. So yeah, just allowing something like PV watts to be used and the kilowatt hours just deducted from the bottom line, that makes complete sense.
We have seen solar thermal basically disappear because of the decreasing cost of PV, and so I don't think we really even have to worry about it.
Okay.
Yeah, definitely following the 80-20 rule, I would agree. Do we have to cover every single possible scenario? We'll be at this for a couple more years.
Right.
We do still get solar thermal systems, but it's like one a year at AEI, and we're not a small group of people, so rare.
Can you guys hear me?
Yeah, we can. Go ahead, Mike.
One of the things that was in 90.1, I'm trying to find if it's still there or not, was that they specifically didn't allow credit for net metering. You basically only got credit for renewable energy that was generating, offsetting simultaneous electric use in the building. I'm not sure that that's still there, but that was something that the committee voted on. It's based on energy cost, right? And energy, even if you do have net metering, the energy cost, that the utility is paying you is generally not the same as you're paying the utility. So it's not, even if you allow net metering, it's not a straight trade-off. So I don't know that you could just use that simplified approach of just calculating total BTUs created if we're, for those two reasons.
Right, yeah, I'm not sure if that's still there. I remember that because now Appendix G also allows you to take credit for purchased, for RECs, if you purchase renewable energy from so yeah, I'm not sure if that's still there. So basically, what I get from
it doesn't allow purchase of RECs. It allows a system that's on your building, but that is owned by somebody else. If you're leasing it, it doesn't allow purchase of RECs for credit.
Okay. Got it. I see. Okay. Okay. So basically the consensus we have so far is that PV's A should be a building should get credit for PV if it has it. Solar thermal is not, the use of solar thermal is quite minimal at this point of time, so maybe we don't need to worry about that. Because the energy generated from PV is quite independent, does not interact with the building loads or building system, we should allow the use of some other tool to estimate the PV energy generation and then just allow the adjustment of the energy consumed on site to this calculation outside of the tool.
So that would assume that the cost of the PV is worth the same going either direction. I mean, the cost of the electricity is the same. Is that, for those of you that work on programs like that offer incentives for renewable energy and you're using a simplified approach, is that how you do it?
Usually renewable stuff is in a different program than the efficiency stuff.
Okay.
Yeah, it's just a different incentive path in a different department.
Right.
It's Shanta here. In my experience, we include a different rate for the PV if it's required. It changes depending on where you are.
That's
right.
my experience as well. Utility to utility, incentive program to incentive program, the rules are different. So I guess it's getting up to the tool developers to, if it's used for utility incentives, of having the flexibility and the tools to account for that. From a code compliance perspective, I'd say it's the same thing. If you can, a percentage of the energy will be consumed within the building and a percentage will be exported. And how to really line that up effectively is probably not the easiest thing to do. Because you're getting down to
it's not done within the same tool.
Yeah, I mean, you could again manually, take an hourly output from both tools from electrical and then do offsets, and whatever's left over gets exported. But I don't know if that qualifies as simple anymore.
Anyone have a sense about how much we're talking here of export? I mean, so assume a relatively small building, roof area is mostly covered with PV, maybe. Decent electrical systems, add code to get your electrical load down. Like, are you even exporting that much in that scenario?
Unless somebody's going big. Unless somebody's going big and covering their parking lot too, or something like that. Yeah, you're probably not seeing a whole lot in the way of export. Maybe on a single story building is probably the almost worst case scenario for what that is. You guys could grab a couple of prototype buildings, a single story ones, and throw PV on the roof and generate and see if you have export condition that often.
Well, the baseline energy use, below which the building never goes, is usually about 20-ish% of peak energy use, right? And the 90.1 requirement that just went in for a quarter of a watt of PV per square foot of conditioned space, that's providing you with about 1% of your, or less, of your energy use. So you have to get a pretty substantial array up there before you start exporting energy, even if you're a warehouse.
And Mike Rosenberg, has Appendix G considered different, maybe I'm just not aware of this, different rates for export versus energy consumed on site?
Well, like I said, they used to not allow any credit for energy exported, and I'm trying to see if that's still in there, if it was changed. And I have to go back and trace through the addenda. I'm not seeing it in 2019. In 2016, it certainly said that it's electricity, renewable energy used on site. It clearly says that. 2019, I don't see that, so maybe that was purposely taken out.
But we decided that since many parts of the country don't allow any kind of net metering, that we make it such a little requirement that nobody would ever be exporting. But in places like here and California, it basically just makes your meter run backwards, essentially, and so you're getting full retail value for it.
On one of the last systems,
full retail value.
Yeah, because it just gives you credit. If you for we always have too much on our house in the summer, and it just gives us credit that gets used later in the year for that same amount of electricity.
Okay, so
I think that's unusual to me.
I have two different scenarios on projects that I'm closely familiar with. One actually has 2 meters on it, an in meter and an out meter. And so they actually have call them two bills, one being a bill and one being a credit, and they just cancel the credit applies to the bill. In that case, it's also right around 10-15% of the building, as is one example. That building's probably about 10 years old now, 8 years old. Another one here in Madison where the utility has you're able to net meter for the year as long as you end up with a bill larger than $0. If you have a net bill for the year that you have been a net producer, your category changes, and so you're now considered an energy producer and not a consumer, and so the rate you get plummets pretty bad. So I mean, utility rates are, they're all over the place, and they can pretty much, it's simplified, exaggerated statement, but they can pretty much do whatever they want as far as creating rules, where they can get passed through utility commissions and so on. So there's no one size fits all here. It's all over the place.
Right. Okay. We're 5 minutes over time. So we'll look into this. There's this discussion on what the rate for energy export should be. And this is quite fascinating, honestly, that some places give you the retail rate for export and some places just change your status to a producer and things change.
And some places give you have no net metering at all. A lot of jurisdictions have no net metering.
Yep.
I did confirm that it looks like they specifically changed that requirement in 90.1 where it no longer says consumed on the site. So that was probably done purposely.
Actually, yeah. Before folks start leaving, I just want to quickly cover our next steps. So we'll leave all of this right now. So next step, we'll be sending out the rule set for review. A lot of you have already reached out and said this is something you want to review. And I don't want time to be an issue for anyone. So if you think that you have limited time, then just let me know. And maybe we can help identify sections that we could really use your review on. That would be really beneficial. And just a quick overview of what the structure is going to look like. We have kept the existing Appendix G structure. So you do have the same section G1, and G1 would apply to both PRM and SPRM. And there's a parallel new section for SPRM. So where G2 talks about simulation general requirements with the weather file, simulation programs, there is a section G4 that has been added for SPRM. And the only difference in G4, so in any place if SPRM is the same as PRM, then it would just say refer to section, the parallel section in G2. And if it is different, then it would just add the additional requirement. And same for G3, which is the calculation of the proposed and baseline building performance. We've added a G5, where it talks about the calculation of the proposed and baseline building performance for SPRM. So hopefully this will not be too confusing. But yeah, this is what it's going to look like. And we'll be sending this out in the next couple of weeks or so for to all of you, hopefully, and you can make some time to take a look at it. I hope people are still around and not everybody's dropped off, but let's see. Okay, a few of us are still here. Great. Anything else before we end today's meeting?
Not for me.
No.
Great. And for us to just stay in touch, I guess we'll continue on emails. And if we at any point of time feel like we need another meeting, either to discuss the comments that you send us, or we have results from the validation test that we want to share and a meeting might be more helpful, we'll just communicate through the same email address that Mike Wilson set up, the SPRM email address. So, and yeah, hopefully we'll have a few more meetings in the future, but let's see how things go. This has been really helpful for us. For all the input that all of you have provided, it's not only made this a more exciting project, but we also feel like this concept is something that folks are interested in, and they see a huge amount of use and potential for this, which has been very encouraging. So thank you, everyone. We appreciate the help.
Great. Thank you.
Thank you.
Yeah. Thank you. Bye-bye.
Bye, everyone. Thank you, Supriya.
Yeah, definitely. Thanks, Mike.